Good day, I am Paul Antonio Novate and I will present to you the number systems and codes. So a brief introduction, a number system is a system representing numbers. It is also called the system of numeration, and it defines a set of values to represent a quantity. These numbers are used as digits, and the most common ones used are 0 and 1. These are digits that are used to represent binary numbers. Digits from 0 to 9 are used to represent other types of number systems which we will tackle. A continuation, a number system is defined to be as the representation of numbers by using digits or other symbols in a consistent manner. The value of any digit in a number can be determined by a digit, by its position in the number and the base of the number system. The numbers are represented in a unique manner and allow us to operate arithmetic operations such as addition, subtraction, and division. So let's get to the first question. What are the different number systems? So based on my research, I have found that these are the binary number systems, which has a base of 2, the most common; octal number system, which is a base of 8; decimal number system with a base of 10; and hexadecimal number system with a base of 16. So second question, explain each code and where can you find them? So first, for our binary number system, I'll explain that this binary number system uses only 2 digits, as I mentioned before, which are 0 and 1. The numbers in this system have a base of 2. Digits 0 and 1 are called bits, and 8 bits together make a byte. The data in computers is stored in terms of bits and bytes. The binary number system does not deal with other numbers such as 2, 3, 4, 5, and many more. So for example, we have examples of binary number systems which are base of 2, only consists of 2 digits. And where can we find binary number systems? So binary numbering system is the basis for storage and transfer and manipulation of data in various computer systems and a wide range of digital electronic devices. So basically, binary system is used everywhere for our electronics purposes. Next is the octal number system. The octal number system uses 8 digits 0 to 7 with the base of 8. So an advantage of this system is that it has lesser digits when compared to several other systems that we'll be mentioning here. Hence, there will be a fewer computational errors. Numbers like 8 and 9 are not included in the octal number system. Just as the binary, the octal number system is used in many computers but with digits from 0 to 7. So examples of these are 35, 9, 23, the base of 8, 141. So as you can notice, it has a base of 8. So where can we find octal number systems? It is widely used in computer application sector and digital numbering systems. The computing systems use 16-bit, 32-bit, or 64-bit word, which is further divided into 8 bits. So the octal numbers system is also used in the aviation sector in the form of a special code. Next, we have the decimal number system. The decimal number system uses 10 digits, 0 to 9, with a base number of 10. The decimal number system is a system that we generally use to represent numbers in our real world. So for example, 723, 32, and 4257. All of these have base 10, are examples of the numbers in a decimal number system. So where can we find decimal number systems? First of all, in arithmetic operations and mathematical solution equations and many more. And also dealing with money, weight, length, etc. when measuring certain values that needs a wide range of numbers, decimal system is appropriate to be used. So the last system is hexadecimal number system. And the hexadecimal number system uses 16 digits or alphabets such 0 to 9 and A to F letters with a base number of 16. Here, the A to F letters of the hexadecimal system means that the numbers 10 to 15 of decimal system it is represented from A to F, and it is 10 to 15 respectively, up to 15. The system is using computers to reduce the large strings of the binary system. So examples, uh, as you can see, the examples are alphanumeric. It is a combination of letters and numbers. Where can I find hexadecimal number systems? First is locations in memory. Hexadecimals can characterize every byte as two hexadecimal digits only compared to 8 digits when using binary. Another common use of hexadecimal numbers is to describe the colors on web pages. Each of the three primary colors, such as red, green, and blue, is represented by two hexadecimal digits to create 255 possible values, thus resulting in a very uh, large number of possible of colors, 16 million. So we go to the third question. What are the different digital codes? So based on my research, here are these codes. First is a binary coded decimal, or commonly known as BCD. So it is a system of writing numerals that assigns a 4-digit binary code to each digit coming from 0 to 9 in a decimal base numeral. The 4-bit BCD code for any particular single base 10-digit is its representation in the binary. So for example, the number decimal representation 37. So every digit is represented in binary. 3, such as in this code, and 7 will be represented with this binary code rather than converting this whole to a straight binary notation. So next is the American Standard Code Information Interchange. So next, this one is the standard code for representing characters. It consists of 128 characters, including letters, numbers, punctuations, and symbols. Each character has been assigned a unique binary string. Next is the Extended Binary Coded Decimal Interchange code. This one, it is a data encoding system developed by IBM and is mostly used on its computers during the early days of electronic revolution that uses a unique 8-bit binary code for each number and alphabetic character, as well as punctuation marks and accented letters and non-alphabetic characters. Lastly, we have the Unicode, which is a universal character encoding standard that assigns a code to every character and symbol in every language in the world. Since there are no other encoding standards that supports coding in all languages, Unicode is the only encoding standard that ensures that you can retrieve or combine data using the combination of any languages. The Unicode is required with the XML, Java, JavaScript, LDAP, and other web-based technologies. So the fourth question, explain what are the typical applications of each of the codes, or what specific application can you find them. So first, for the binary coded decimal, is commonly used for displaying alphanumeric numbers in the past, but this time in the modern day BCD application, it is used with real-time clocks or RTC chips to keep track of a wall clock time, and is becoming more common for embedded microprocessors to include an RTC. It is very common for RTCs to store in the time of the BCD format. So another extension of the applications, frequency counters, digital multimeters, or digital calculators. So any of this. Next, applications for the American Standard Code Information Interchange. They represented texts within the computers or telecommunications equipment and other devices that uh, show characters and symbols which go beyond the scope of BCD. Next is the extended binary coded decimal interchange code. This 8-bit character encoding is widely used in IBM mid-range and mainframe computers, so it was really this code is really old, and it dates back since 1950 and 1964. So lastly, the Unicode. Unicode is a preferred text encoding method within browsers such as Google Chrome and Mozilla Firefox. Unicode is also internally in Java technologies, HTML, and Windows and its Office applications such as Microsoft PowerPoint, Excel, and many more. So thank you for listening.